For adding and subtracting radicals, we cannot add radicals the way this is because we know that adding and roots just don't mix. So to do addition of radicals, what we need to do is we need to write it in its mixed radical form. And if the radical parts are the same, we have what we call like radicals, and then we can count those radicals together or add them up. So it looks like this. The first thing is we need to write the root 72 in its mixed radical form. So we need to take out the perfect square. So I'm going to take out my perfect square of 36. So I end up with 6. And then when I divide by 36, I'm going to be left with 2. So I end up with 6 root 2. The same for the 50. I need to take out the perfect square of 25. Square root of 25 is 5. And then what's left over when I factor out the 25 is going to be 2. So here we have our mixed radical forms. And once we have the mixed radical forms, we look for like radicals. Like radicals means that the radical parts are the same. So what this expression is saying is we have 6 groups of root 2 plus 5 groups of root 2. Well, if we have groups of root 2, we can add up those groups. We can add up those root 2's, and we end up with a total of 6 plus 5 is 11, and what we're counting is the root 2's. So we end up with 11 root 2. So if we add root 72 plus root 50 on our calculators, it's going to be the same as 11 times the square root of 2. And again, to do this, we need to make it into mixed radicals and then look for like radicals. Okay, so when we talk about like radicals, it's when the radical parts are the same. For cube roots, we need to do the same thing, but we need to take out our perfect cubes. So we need to know our perfect cubes. So when we look at the first one, we have 3, and then cube root. The biggest perfect cube that will divide into 135, well, we can try 1, 8, 27. 27 will divide into 35. So we get 27 times 5. Okay, 27 is a perfect cube. For 320, again, we're looking for perfect cubes that divide into 320. Okay, 8 will divide in, that would work, but the biggest one that will divide into 320 is going to be 4 cubed, which is 64. So I'm going to write this as 64 times, when we divide out the 64, we end up with 5. So because we have a cube under a cube root, we can rewrite that as a cube root of 3 cubed. So that undoes each other. And then left over is going to be the 5 inside the cube root. So same thing here, we're going to cube root. 64 is 4 cubed. So those undo each other. And then we're left with times by cube root 5. So simplifying this then, we end up with 3 times 3, those undo each other, cube root 5 minus the cube and cube root undo each other, so we end up with 4, and then left over is cube root 5. So this becomes 3 times 3 is 9. We have 9 cube root 5's here, and we're taking away 4 of the same thing, cube root 5. So we have 9 of something, and we're taking away 4 of the same thing. We're going to be left with 5 of whatever we're counting, and becomes 5 cube root 5. So we have 5 cube root 5's is going to be equal to that original expression.